everyone, my name is Alda Cahyaningtyas. You can call me Alda. This is going to be my interactive presentation number 4 for the General Chemistry 1 course that I'm taking with Doane University. I'm sorry for the weird angle because I'm kind of limited in terms of space, so we will have to work with this limited space today. However, I really hope that you're still able to get the key takeaways from this video despite the weird angle. So today, I'm going to be showing you how to make a balloon fireproof with the help of water. I'm going to be carrying the experiment, and then afterwards, I'm going to show you the explanation of what's happening in the experiment. So let's get started. So first, I have here with me several balloons. Well, actually not several, quite a lot of balloons. But we're only going to be using 2 only for this experiment. So I'm gonna pick out the green one, and also I'm gonna pick out a pink one. The color doesn't really matter, it's just so that we can differentiate which one is going to be filled with water and which one is going to be filled with just air. I'm gonna put this aside, and then so other than balloons, we also need an igniter. So I have with me kitchen igniter that I actually use to light up candles, but any igniter will work for this experiment. It's just this one is available to me right now. So I'm gonna put this here. I'm just gonna stretch the balloon first, and this one as well. Now, for the pink balloon, I'm only going to be filling it with air and no water. This is enough, and then you tie it. Here you go. And now we put this aside, and now we work on this balloon. So this one, we're going to be filling it with water first. And now we're going to blow the balloon and tie it. There you go. And now we're going to put this aside. I'm going to be showing you how this is just regular balloon. So in order to show you that this is just regular balloon, I'm going to ignite the igniter around the balloon area or surface area. So let's do that. I'm actually kind of scared of balloon popping sound or popping balloon sound, but here we go. Oh my god. Oh, okay, it's a regular balloon. It popped. Now let's put that aside. This is the second balloon with water. I really hope that you can see it, that there is water in here. I'm going to ignite the igniter in this area where the water is. So you see how this balloon still becomes or turns black? That's where the fire or the heat was applied to the balloon. So this balloon has water inside and it didn't pop, and we've made a fireproof balloon today. With the experiment that we just did, with the balloon filled with just air being the control group, and the balloon that's filled with water and air being the experimental group, we were able to observe a fireproof balloon with the experimental group. The reason why this happened is because the water in the balloon served as a heat sink. The reason why the water in the experiment served as a heat sink is due to the fact that water has high specific heat capacity. Because of its high specific heat capacity, it was able to absorb the heat that was being projected onto the balloon and preventing the balloon from popping. Another effect of the high specific heat capacity of water It's also causing the water to require more energy in order to raise its temperature. That's why it's avoiding the balloon to pop. The water inside the balloon also dissipates the heat. What that means is that the water is now able to distribute the heat more evenly compared to the balloon that doesn't have water in it. A localized heat spot or hot spot, like the one that we observe with the balloon without water, accelerates the popping of the balloon due to the fact that when heat is applied to the balloon without water, the air molecules in it now collides and have high activity inside of the balloon, causing the balloon to expand and stretch and later on pop. Now we have learned that the material of the balloon, when water is present, didn't just suddenly become fireproof. What actually happened is that water helped to regulate the pressure inside of the balloon and also dissipate the heat, avoiding localized hot spot, and in turn, avoiding the balloon to pop. Thank you so much for watching this video. I hope you find it informative. If there's any mistake or error within this experiment or video, please don't hesitate to reach out to me and I'll be more than happy to correct it. Thank you so much once again. Bye.